lots of information to absorb. I hope you still have a couple of neurons to keep track of this. So as Steve mentioned, this is a new working group. We have been cooking this for several months. Logistics, lawyers, admin just delayed everything, but yep, it's alive since two weeks now. And okay, today we have like 30 minutes now. So I'm going to give you a little introduction to the working group, why I'm trying to do this. We are still learning. And then Andrea is going to give you a little of view what people are really doing for LEO constellations in Europe. Later on, it's not really a panel, but I would like to open discussion, including also Tommaso's presentation in the morning. You can kick also that topic if you are interested on that. Okay, so the scope of the working group, as the word says, is to look at everything that flies. Is if it flies and have some computational capability on board, then we may theoretically do a computer network. Right? So we are talking about not only satellites that people immediately think, LEO constellations, but also everything. Commercial aircraft, military aircraft, drones, hubs, everything that flies and have a computer on board. There is a very heterogeneous system. We don't have a data center in the space, so not that kind of capacity, but some interesting services could actually be deployed. Maybe some services that you don't think about, but that's why the working group is here. So the idea, or that we are trying to look at, is to look at this aerospace data communication system as a large-scale internet. Right? In Europe, there are lots of discussions about 6G NTN. The first word is 6G, is not NTN. For me, it should be NTN 6G, but it's not. It's the other way around for some reason. And I think the integration should not be with 6G, I will explain that. It should be about internet. Internet is data communication. Everything that has to do with exchanging data from point A to point B, formatting the data, protecting the data, storing the data, that's what we should be looking at, not the technology to access that data, right? Just because I'm connected to a 5G access point, a wireless point, that should not matter. Right? That is like kind of a small vision, in my opinion. So, in the web page you have lots of things that we look at, from the potential future themes or use cases. Here I just mentioned three. Okay, all of these that we mentioned, I think, in the web page are about aerospaces. So we should look at aerospace use cases, but today I learned that maybe we can go a little further away, railway. It also moves, it's not flying, but maybe we'll benefit from a satellite communication. If we can put a satellite dish on an aircraft, we can put it also in the train. That's not a big thing, I think. So, but things like air traffic management currently is completely centralized. You need to talk with a human guy that commits errors. You need to control with other human guy with computers. It's like a nightmare, right? So, what if we decentralize it? What if we allow aircraft to talk with aircraft and learn where they are and to take some local decision, not very life-threatening one? Maybe what happened in Washington DC between that helicopter and aircraft will never happen. Aircraft operations, everything about IoT, right? We're thinking about exporting lots of quantities of data out of the aircraft during flying for maintenance. All these are potential topics. Space communication, I put about that later. So this is just ideas, but overall, the idea is to look at anything that we can do with a flying computer. For instance, cybersecurity. I'll give you an example. You send traffic over Starlink. You use TCP/UTLS or QUIC. Okay, there are problems using QUIC, okay, but let's not talk about that anymore here. But everything suppose is encrypted end-to-end. What about the metadata? What about your packet headers? What can I infer about you by looking at your packet headers? Right? So that maybe raise some kind of privacy there. Reliability. Data compression, for instance. Of course, everyone flight and everyone had a optimus experience using the internet while flying, I think, right? You play your favorite games, I think, come on. I don't know what aircrafts are you talking about. But So we have lots of things to do, and we are envisioning that in the future, the bottleneck at aircraft is like a mobile network, like a train. In the Internet, there was a huge amount of work, I don't know many years ago, about mobile networks. Everything died because no one is using that. Aircraft, A350 has 440 people on board, trying to do the best they can for 14 hours in a flight to Tokyo, right? So, and they are using currently an antenna that is connected to something that is flying 35,000 kilometers away, right? In the future, it's going to be connected to a LEO constellation. Okay, it's good. You have 200, okay, let's assume Starlink as a starting point. Maybe Andreas does not like it, but let's assume it for now. That is 220 megabits per second. It's already better. But in the future, I think we can have like, I can talk about itself, like double connectivity inside the aircraft is already half of a gigabyte per second inside the aircraft. It's already okay. But 440 guys and ladies eager to use gaming and video calls is not enough. So we always look for the bottleneck. So things like maybe data compression, AI for data compression, right? Could be interesting to look at. Long story short. Data management. What if I start putting data on board? So why should I export IoT data from the aircraft, raw data to my data center, thousands of kilometers away, to be stored and processed later on? Why can I process it on board the aircraft and exporting just the outcome of it, what I learn from it? Because at the end user doesn't care about raw data, care about the knowledge that I can extract from the raw data, right? Unless I need to correlate or to connect this raw data from aircraft A to aircraft B, even so, if I have something very nice that allows aircraft A to communicate with aircraft B over a satellite system directly, they could decide what to do with that data before the data comes to ground. Privacy protected, very cheap service, a percentage of the data coming to ground. That's kind of another way to look at it. So in-board computing concepts, so I try to give you some kind of idea, like the case of the aircraft, of technologies that already exist, and some of these technologies died or are in dormant mode, like in ITF there were a lot of work about multi-home devices, HIP, and all that stuff. Aircraft with two satellite connectivities are a multi-home device. What do I do with them? Even if they are connected to the same constellation, Starlink again as an example, they are connected to different satellites, which are in different orbits, which are in different optimal paths toward the destination. Should I just connect randomly to one of them or not? So this is an example of this kind of datacom technologies could be used, and they are not. And I could go over and over, give you an example of how to use AI for automatic deployment of hubs combined with UAVs over Ukraine because Starlink shut down the network and they had no way to communicate. How can AU 1 month deploy a network with 10 hubs over a distance of radius of 600 kilometers with some UAVs on the ground for amplifying signal from different vendors that never talk to each other again? How do we do that in an automated way? How do the routing work? Right? How can they agree on the fly about that? So all of those are important use cases. How can we do that? We are very far away, like the railway guys are much in front of us. We are learning with your case. I really enjoy your presentation. We try to do like the normal stuff. We can look at service and ecosystem. Let's define a use case. Right? We can try to find the interesting people and work on a white paper about what exactly means datacom for NTN over in the future. I put that in the next slide. We also can do design and architecture, a little more of the use cases or requirements, more looking at the technical part, like was mentioned before about about the 5G new generation. Just identify a specific technology and look at that. Currently, I have no idea, open to ideas. And currently, this is like a one-man show, should not be, right? Starting tomorrow, this should not be a one-man show. Let's work on that. Policies and governance. It's really important. And because, for instance, again, when you use Starlink, all your data goes to US territory. As soon as your packet gets a satellite, they apply US law. And then, as you know, Starlink has, I think, around 33 hops, because Starlink is an autonomous system. is flying internet. They peer with 33 other operators, 14 of which are in the US. So most likely your data, when you go to Starlink, goes to the US. And then goes in a submarine cable somewhere. So it's not like a global internet, right, that provides connectivity. So that's also a problem. So, you see, there are lots of people involved on this. No, I'm kidding. These are just potential people and entities that I see as we could benefit from their presence. They may benefit from the AI. But like Dirk said, this just happened 2 weeks ago, and this time to start picking up the phone and contacting people. But you see, there are lots of people. So, everybody's here. Andreas, I was right. You're here since the beginning. Because I was telling Andreas, because this list, I did not make it yesterday. It was made like several months ago. From academia, not that I want to discriminate no one, I just pop up very quickly universities that have some kind of aerospace-related department. For instance, I give the example of TUM. They have aerospace department in Ottobrunn, the Airbus, but actually the people that I collaborate most closely are in Garching, because they are from the computer department. So it's open to everyone, just an easy idea. So this has some possibility to grow. What can we do? Lots of things. Give you the example, again going to satellites. Currently we have this, I think Tomas also showed something similar. So in 3GPP we are saying we have these operators in the ground that have a massive network here, and we try to use this damn satellite to extend connectivity. They don't care if this is a data communication entity, it's just a pipe. And they want to reach this end user or actually a runner. That's the business model from the 6G NTN in general. And then there are other subcases, right? And if we see from, for instance, the Starlink point of view, because Starlink, as I mentioned, is an ISP, has a set of IPv4 addresses, IPv6 addresses. Actually, they behave very poorly. If you analyze how they do it, so just look at how they allocate IP addresses. They are ISP, but they use network address translators 3,000 kilometers away. So normally NATs are used inside your company. They do it on the other side of the globe because they use private IPv4 addresses on inside. Mobility is out of the scope. If you try to buy a Starlink antenna, put on a train or your car on an aircraft, you pay $12,000 a month for the service. With the same equipment and same software that you pay for a $200 subscription to home. So they just want to avoid people to use it. Why? Because they cannot manage it. Currently, what they do is that they give IP address from the closest POP. So if you live in Washington, you get IP address from a POP in New York State, and all your traffic goes from your house to New York State and then through the regular internet. So it's hot potato, right? They read out of traffic as soon as they can. They provide nomadic services. If you want to go to your house in Hamptons, you need to buy a second dish because you cannot use the first one. Because the first one is hard-coded to that POP. Right? Can we solve this with Datacom? Yes, we can. Right? It's very easy to do mobility management using ITF protocols to allow a mobile device that in the future, suppose it's going to be directly connected to a satellite, just to have seamless connectivity over a Starlink or a LEO constellation. It's easy. So again, someone in the morning asked, so if I can do this, why do I need the mobile operators in the ground? Okay, there's still the problem that in a metropolitan area, all the antennas that are deployed on top rooftops have better coverage and better signal than a satellite moving very fast on top of you. But let me just finish with a remark. The relationship between a LEO constellation or internet connectivity from LEO constellation and a cellular network is the same relationship between a cellular network and a Wi-Fi. Long time ago, we had Wi-Fi inside buildings and with cellular outside. And the cellular system tried to come inside with femtocells and it did not go very well. So we also have the satellite system providing global connectivity. And when you go to a metropolitan area, you can roam to your local one. It's not the other way around. So for instance, when you roam, that could be a business for Starlink. Roaming. You go from Europe to US, instead of being charged by roaming service from Vodafone because they have an agreement with Verizon, you have one global roaming partner that is Starlink. Wherever you go, use Starlink. In your hometown, you use your preferred one. This could be a way to go. Why don't we flip it around? You have a contract with, I'm not selling Starlink. You have an agreement with your Leo operation, can be Rivada, can be others, to operate globally, wherever you are, even in Starnberg, that is 20 kilometers from Munich and there is no coverage from cellular communication. And when you get to an area where a local provider, a local access network, Vodafone, provides you better service, then you switch over. Okay? And with this, I just want to tell you that I think the sky is the limit. Or as we say in the Aerospace, the sky is not the limit, we go above it. But I can give you the floor to Andreas. Let's keep maybe the questions to the end. Right? So I think Andreas will give us a little idea what Europe is doing.
Thank you, Paolo, and also nice afternoon from my side. Andreas Isel is my name, you can read it there. So, some of you in the audience know me from my previous life, and most of my life I was not in the space industry, in fact only since the last 2 years. So I had a career more on the terrestrial and there even more on an more international backbone network sites, IP optical networks end to end. And why this fits very well with what we are doing here in Rivada, I will show you in the next 5 to 10 minutes. So I'm with Rivada Space Networks. Who knows Rivada Space Networks? Who has heard about it? Okay, a few of you. So Rivada Space Networks, we are a network operator, or to be more precise, we are a startup that is going to be a network operator. So we are planning and building a LEO constellation-based network, we call the Outernet, to create global connectivity. And in a way, this now everybody thinks of Starlink at this point in time, and we are very different from what Starlink is doing, and therefore we are also not really a competitor of them. In fact, we're using SpaceX launch facilities even to launch our satellites. We have very good relationships with the guys over there. What we are doing is we provide connectivity across the globe, and more connectivity for enterprises and governments. So really more the big pipes in a global connectivity, in a global constellation with direct end-to-end routing in space. So our user traffic never reaches the ground, only at the endpoints, at the ingress and the egress. This is, I think, the main differentiators, and this is what our customers are valuing. At the moment, we have a pipeline of already 17 billion MOUs signed up of potential customers who want to use our service. So MOU is still something early, but at least it shows there's a high interest. It's on the one hand, governments, of course, security forces there, militaries, embassies, but it's also a lot of commercial customers, big companies who want to have connectivity, global connectivity, even in difficult situations. And a nice or not so nice story is, recently there were these cable cuts in the Baltic Sea. You all remember, I think from Finland to Poland or something. And whenever such accident happens, our CEO receives a lot of phone calls over the weekend, because at that point in time everybody sees how vulnerable we are on ground. And even while a space-based connectivity cannot replace fiber connectivity on ground, at least it gives some backup and reachability of your remote sites in difficult times. So technically what we are doing, so we will have 600 satellites in low Earth orbit, flying on a little bit more than 1,000 kilometers. This is about twice as high as Starlink is flying. If you fly at this height, you can theoretically cover the complete Earth with about 80 satellites, 80. We have more satellites to have better coverage and to be more resilient to weather conditions, for example. but still much less than the thousands that Starlink is launching. We are organizing that in 24 polar orbits. So a lot of terms you may not know, I also needed to learn all of them. Polar orbit means that the satellites are all flying almost across the poles. And this has the advantage that you can also reach the poles. Most of the other constellations are flying somehow not over the poles, and this means you have a good coverage on the more populated areas and not on the poles. That's why they're doing it. But this means that we have a lot of customers who want to have it at the poles. If you think of military customers, they also want to have their vessels on the poles supported. So we are flying the poles and therefore have a real global coverage. We have 10 gigabit throughput of traffic from ground to satellite. I think in theory even up to 20, but in practice probably more towards 10. And then also 10 gigabit on the inter-satellite links. We are operating in the Ka band. That's around 20 gigahertz with different frequencies for up and down links. So these are some of the technical parameters. Gateway-less. That's, as I said, end-to-end. We never reach the ground. We never break out on a ground gateway to this little clouds people are drawing in the nice NTN drawings. We don't have that. Our cloud is in the sky. We are not an ISP, so we're not connecting to the public internet. In fact, we are even proud not to be even connected to the internet. So our customers may want to do that. They can connect their headquarters to the internet if they really want to. But through our network, they will not reach the internet through us. By the way, this also means that we don't need an ISP license, which is a nice benefit for us, simplifies our life. Technically, so this is, everybody's looking, of course, what are the satellites doing? In our case, we flying routers on board of the satellites. We're using an MPLS-like protocol, so nowadays this is segment routing and improvements of that, which sounds quite straightforward. If you're on ground, in my previous life, having a router running tens and hundreds of gigabits, straightforward, no problem. Building an MPLS or a segment routing router in space, unlimited space requirements, weight requirements, power requirements, that's quite challenging. So I'm going back to the first days of my career, that we were building routers on FPGAs, and this is what we're doing here in space. So really like switching back in time. So it's called regenerative payload, so this means there is this routing, there is intelligence on board of the satellite. Our satellites are about the size of a dishwasher, and we have there the compute power of something like 8 to 10 CPUs, not more. And we need to use that for control, management, forwarding, all of that. So it's a limited capabilities, and this is when I'm hearing that people are thinking of having data centers in space, not on this type of satellites. Of course you can do that, but then you have complete different beasts of satellites, and you need to launch them, operate them, so it's not as easy as it sounds. I think we can go ahead here. I use that slide not because it's showing the various types of user terminals we can support in various sizes, but because this was one of the only ones where we're seeing that network quite nicely. So we have like a very structured network in space where each satellite is connected in 4 directions with optical inter-satellite links, so 10 gigabit in 4 directions. So like on a sheet of paper, you can imagine that you can route now through all that constellation. And since all the satellites are flying in the same direction, it's a quite stable network. Your neighbors do not really change a lot, with some exceptions. There's a so-called border where the constellation reaches the other end of the flying satellites. But other than that, it's quite stable. And what really is changing is, of course, the link from the user terminal to the satellite. There you need to do handovers, and that's happening about every 5 to 10 minutes. And 5 to 10 minutes also sounds quite okay-ish, but if you then think that there are 10,000 of user terminals and they are all changing every 5 minutes, That's quite some amount of handovers. And all that then also needs to trigger rerouting in the network, because it's not only handing over the next satellite, and then if you would be Starlink, you just go back down to the next gateway and you don't care a lot. But in our case, then we need to reroute the traffic and again reach on the other endpoint. Also now the new satellite, because also their handover has happened. So this is a quite complex routing and rerouting challenge we are facing there, and a lot of technical problems that could be discussed or solved. Yeah, so since we are short in time, I think I mentioned more or less most of those topics. Our differentiators, we are symmetrical, I didn't mention that, so most competitors have a, like typically also for traditional DSL, for example, much more down than uplink. We are symmetrical due to the nature of our customers. We are gateway-less, I mentioned. We have the complete global coverage. Low latency, I didn't mention. You can do calculations that if you go in space, where you can go directly more or less end-to-end, you can be faster than if you go on ground, where you may need to take longer ways, and where you have to run through fiber. And fiber also, as we all know from physics, fiber is slowing down the light by 2/3. So I think we did calculations going from Europe to Australia, you are, I think, 30% faster if you go in space compared to fiber. Layer 2 connectivity, maybe that's another important point. We are standardizing our service offering based on Metro Ethernet Forum, MEF, or I think they renamed now to Amplify, but MEF is maybe known to all of you. MEF specifies the so-called E-line, E-LAN, E3 standard. So Ethernet, layer 2 connectivity, point-to-point, multi-point, and there is a lot of books and specifications on how these services need to be built and need to be operated, and we are completely following those standards. This is what every leased line provider is doing. They are offering leased lines based on MPLS, and that's what we are doing. We're offering leased lines based on MPLS-like technology in space. This is more or less where we are seen. Also, SLA is an important topic there. So since it's enterprise services and government services, we are very much looking at SLAs. And with that, I think I'm already at the end. And I don't know how we proceed from here.
So I think now
maybe questions to me, or
how
then
long do we take? We have what, 10 minutes more? Or?
We only have 15 minutes for the panel, but we're going to do the panel as a pitch. We're going to refactor things a little bit.
Okay, I think we have some time for some questions.
Yeah, do the questions.
So I think we can open the floor.
Maybe one thing I didn't prepare, but do that ad hoc. So I didn't know what's happening here. So I was invited only a week ago. I was on holiday before, and I agreed. Okay, if it's in Munich, so I'm living in Munich. Our company is headquartered just a kilometer from here, and then I agreed last Thursday or so that I will come and present about us. But I didn't know what to expect. But from today's discussion, I understand now what DIA is and what we want to do. And just immediate brainstorming, I think there are two areas where we could have interest to work. One is, of course, on all those technical topics, how to solve the routing and then the dynamic updates and stuff. And the other thing is more from the application point of view. So I said we have mainly government and commercial customers, but still also there, looking at what are the typical applications, how do you make an enterprise VPN on something like that, or what other kind of use cases you can find there. I think that will also be very interesting.